Hi, welcome to Step 2 Maths. In this section, we are going to discuss about some problems related to arithmetic progression. First question. In an AP, 19th term is 52 and 38th term is 128. Find sum of first 56 terms. In an AP, 19th term, how we can represent it? T19. T19 is equal to 52. In an AP, 19th term, that we can represent it T19. 19th term is 52 and 38th term, that is T38 is equal to 128. In an arithmetic progression, the 19th term, that is T19 is equal to 52 and 38th term, that is T38 is equal to 128. Find the sum of first 56 term. That is, we have to find out S56 equal to what? T19. How we can represent T19? We know the equation Tn, nth term, a plus n minus 1 into d. So, according to this equation, how we can represent T19? T19 is equal to a. Here only this T19 and T38, these two terms are given. A and D are not given. First term or common difference is not given. So, A plus n is 19. So, n minus 1 is 19 minus 1 into D. D is also not given. So, T19 we can represent A plus 19 minus 1 is 18. A plus 18D. A plus 18D, and that is equal to, its value is given 52. Similarly, T38th term. How we can represent T38th term? A plus n minus 1. Here n is 38. So, 38 minus 1, 37. So, T38 is equal to A plus 37, D is equal to 128. A plus 18D is equal to 52 and A plus 37D is equal to 128. Now we get two linear equations and we know how we can solve two linear equations. We can label this as equation 1 and this as equation 2. So, equation 2 minus equation 1. A plus 37 D is equal to 128, that is equation number 2, and equation number 1 is A plus 18D. 18D is equal to 52. Subtract 2 minus 1. This is 2 and this equation is equation 1. So, A minus A get cancelled. 37 minus 18D, 19D is equal to 128 minus 52 is equal to 76. 19D is equal to 76. Therefore, the value of D is equal to 76 upon 19. 76 upon 19 is 4. From these two equations, we get the value of D. D is equal to 4. D is equal to 4. If we substitute in any of this equation, we get the value of D is equal to 4. And if we know the value of A, then we can find the sum of first 56 terms. How we can find the value of A? we can substitute the value of D in any of this equation. Consider equation number 1. A plus 18D is equal to 52. When D is equal to 4, this become A plus 18 into D. 18 into D is 4. So, 18 into 4 is equal to 52. That is A plus 18 into 4 is 72 is equal to 52. Therefore, A is equal to 52 minus 72. 52 minus 72 is minus 20. The value of A is minus 20. A is equal to minus 20. From the given two terms, that is from T19 and T38, we get the value of D is equal to 4 and A is equal to 20. Find the value of S56. A sum of first 56 terms of this AP. S56 is equal to n upon 2. Here n is 56. So, 56 upon 2 into 2A. 2 into A is minus 20. 2A plus n is 56. So, n minus 1 is 56 minus 1 into D is 4. We substitute the value of n, A and D in this equation. Sn is equal to n upon 2 into 2A plus n minus 1 into D. Simplify these values. 56 upon 2 into minus 20 minus 40 plus 56 minus 1. 56 minus 1 is 55 into 4. That is equal to 56 upon 2 into minus 40 plus 55 into 4 is 220. Minus 40 plus 220. So, if we simplify this, 56 upon 2 into minus 40 plus 220 is 180. 56 upon 2 into 180. If we find its value, it's become 5040. That is the sum of first 56 term of AP whose 19th term is 52 and 38th term is 128 is equal to 5040. Here only two terms are given, 19th term and 38th term. So, 19th term we represented as using the equation Tn is equal to A plus n minus 1 into D. 19th term is A plus 18D and 38th term is A plus 37D and its values are given. That means we get two linear equations. We solve that two linear equations and get the value of A and D. Then substitute that value of A and D in the equation Sn. So, finally, we find the sum of first 56 term of this AP. The next question, sum of first 55 terms of an AP is 3300. Find its 28th term. Sum of 55 terms of first 55 terms of an AP, that is S55 is equal to 3300. This is the only given value. We have to find its 28th term. 28th term we can write it as T28 and using the relation Tn is equal to A plus n minus 1 into D, we can write it as a plus n minus 1, 28 minus 1, that is 27d. We have to find its value. The given value is S55 is equal to 3300. We know the equation Sn is equal to n upon 2 into 2a plus n minus 1 into d. That is the first equation for sum of first n term of an AP. Here sum of first 55 term is given. So S55 is equal to, here we know the value of n only. So S55 is 55 upon 2 into 2a. The value of a is not given. 2a plus n minus 1. N is 55. So 55 minus 1 is 54. D is also not given. So S55 is 55 upon 2 into 2a plus 54d. From these two terms, 2a plus 54d, 2 is common. So we can write this as 55 upon 2 into, we can take 1 2 common. So inside the bracket it will become a plus 27d, and the value of S55 is given 3300. So therefore we can write 3300 is equal to, if we simplify this 55 upon 2 into 2, we can cancel this 2 on numerator and denominator. So it's become 55 into a plus 27d. This a plus 27d, that is the 28th term, and its value we have to find out. So we can write it as a plus 27d is equal to, from here, 3300 upon 55. 3300 upon 55 is 60. A plus 27d, its value is 60, and this a plus 27d is the 28th term. So the 28th term of this AP is 60. In this problem, sum of first 55 term of an AP is given 3300. That is the only given information. We have to find the 28th term of this AP. And 28th term, that is the 28 is equal to a plus 27d. And then the sum of 55, first 55 term of an AP, and here we know only the value of n. Substitute that value, and after simplifying that equation we get 3300 is equal to 55 into a plus 27d, and this a plus 27d is the 28th term, and its value is 60. The next question. In an arithmetic progression, sum of 3 consecutive term is 27 and their product is 504. Find the terms. In an AP, sum of 3 consecutive term is 27. Sum of 3 consecutive term is 27. How we can represent the 3 consecutive term of an arithmetic progression? If we consider this A, normally we take this A as the first term. Here we can take A as the middle term. Among the three terms, A is middle term. So what is the next term? A plus D. And the term before this A is A minus D. A minus D, A and A plus D are the three consecutive terms of an AP. And according to the question, the sum of these three terms is 27. So we can write it as A minus D plus A plus A plus D. A minus D first term, A is second term and A plus D is the third term. The three consecutive term and their sum, that is A minus D plus A plus D, and this sum is given as 27. The next given value is their product. So how we can write the A minus D into A into A plus D. That product is 504. And from this, its sum, if we add these three terms, A minus D plus A plus D, A plus A plus A, that is 3A. 3A minus D plus D get cancelled. So the left hand side become 3A and 3A is equal to 27. Therefore the value of A is equal to 27 upon 3 is equal to 9. We get the value of A is equal to 9. We have to find the three consecutive terms of this AP. A is 9. Now move to its product, A minus D into A plus D. We can rewrite it as A minus D into A plus D. We change the order into A minus D into A plus D into A, and that is equal to 504, and A minus D into A plus D in the form of A plus B into A minus B, that is A square minus B square. So here it is A square minus D square. A minus D into A plus D we can write as A square minus D square into A is equal to 504, and from the sum we get the value of A. So substitute 9 square minus D square into A is 9 is equal to 504. Therefore 9 square minus D square is equal to 504 upon 9. 504 upon 9 is 56. So 9 square minus D square is equal to 56. So 9 square is 81. So 81 minus D square is equal to 56. That is D square is equal to 81. D square is equal to 81 minus 56 is equal to 25. We get the value of D square is 25. D square is equal to 25. Therefore, the value of D is equal to root of 25. And root of 25 is plus 5 or negative 5. Root of 25 has two values, plus 5 or minus 5. So the value of D is equal to plus 5 or minus 5. Now we get the value of A is equal to 9 and D is equal to plus 5 or minus 5. A is 9 and D has two values plus 5 or negative 5. The terms are A minus D, A and A plus D. The value of A is, we have to find these consecutive terms. So the value of A is 9. We have to find these three terms. So the value of A is 9. If the value of D is positive 5, A minus D is 9 minus 5, that is 4, and A plus D is 9 plus 5. 9 plus 5 is 14. If the value of D is minus 5, the value of A is 9, and what about the value of D? 9 minus minus 5. 9 minus minus 5 is 9 plus 5. 9 plus 5 is 14. If the value of D is minus 5, then A minus D is 14, A is 9 and A plus D, that is A plus D here, A plus D 9 plus minus 5, that is 9 minus 5. 9 minus 5 is 4. So the value of A plus D is 4. So the consecutive term of three consecutive term of an AP is, if D is positive 5, the consecutive terms are 4, 9, 14, and D is minus 5, the terms are 14, 9 and 4. Here sum and product of three consecutive term of an arithmetic progression is given. From that we find the three consecutive term. Here the value of D is positive 5 or negative 5. So from given information we can write two possible arithmetic progression. If D is positive 5, the arithmetic progression is, the three consecutive term is 4, 9, 14, or if D is minus 5, the three consecutive term is 14, 9 and 4. The next question. Find 4 consecutive term in an AP whose sum is 12 and sum of third and fourth term is 14. The sum of 4 consecutive term is 12 and sum of third and fourth term is also given. 4 consecutive term. So how we can take that 4 consecutive term? A minus D, A plus D. 3 consecutive term. And the fourth term is A plus 2D. The 4 consecutive term of an AP whose first term is A and common difference D. We can generally represent like this. And their sum is given. So A minus D plus A plus D plus A plus 2D. And their sum is 12. And one more information is given. The third and fourth term is A plus D and A plus 2D, and that sum is 14. So we can write that information as A plus D plus A plus 2D, that is equal to 14. We have to find these 4 terms. First consider this part. A minus D plus A plus D plus A plus 2D. Simplify this left hand side. A plus A plus A plus A. 4A. So 4A minus D and plus D get cancelled and the remaining is 2d. So 4a plus 2d is equal to 12. We can simplify it by dividing throughout by 2. We get 2a plus d is equal to 4a plus 2d is equal to 12, and if we simplify this by dividing this equation throughout by 2, we get 2a plus d is equal to 6. Now from the second part, a plus d plus a plus 2d. So if we add, the left hand side become 2a, a plus a is 2a, d plus 2d is a plus 2a plus 3d. 3d is equal to 14. 2a plus d is equal to 6 and 2a plus 3d is equal to 14. We get two linear equations. So we can write 2a plus 3d is equal to 14. This we can label as equation number 1 and this is equation number 2, and if we simplify, that is we can subtract equation 2 minus equation 1, 2a minus 2a get cancelled, 3d we subtract equation 2 minus equation 1, that 3d minus d, 3d minus d is 2d and 14 minus 6 is 8. So 2d is equal to 8, therefore the value of d is equal to 8 upon 2 is equal to 4. We get the value of d is equal to 4. Now substitute in equation 1, 2a plus d is equal to 6. If d is equal to 4, 2a plus 4 is equal to 6, 2a is equal to 6 minus 4, 6 minus 4 is 2a is equal to 6 minus 4 is 2, therefore the value of a is 2 upon 2 is equal to 1. We get the value of a is equal to 1 and d is equal to 4. Here d has only one value. So the four consecutive terms are a minus d, a plus d and a plus 2d becomes a minus d, that is 1 minus 4. 1 minus 4 is minus 3 and a is 1 and a plus d, that is 1 plus 4 is 5 and a plus 2d. 2d is 4 into 2, 8. 8 plus 1, 9. So the four consecutive term of AP whose the sum of four consecutive term is 12 and the sum of third and fourth term is 14 are minus 3, 1, 5 and 9. And here we take the four consecutive terms are a minus d, a plus d and a plus 2d. When we consider three consecutive terms, we take the terms are a minus d, a and a plus d. Thank you.